here's the part that got me. For 2 days, if you didn't answer your AI coding assistant's question, it answered it for you.
Wait, back up. Answered it how?
The tool that's supposed to stop and ask, should I deploy this? Should I run that command? If you stepped away for a minute, it just picked one.
On its own best guess.
On its own best guess, your silence counted as yes.
And everyone assumed the opposite, right? You ask a question, you wait for the answer. That's the entire point of asking.
That's the entire contract. And they shipped it, flipped on the 1st of the month, pulled it 2 days later.
48 hours.
48 hours and the whole developer world lit up, because it was never really about one time out.
No, it's about where the decision lives. Who has to say yes before a machine does the thing?
And that, weirdly, is the thread under everything today. Research agents that lose the plot halfway through. Game worlds that can't remember what you smashed.
Same question over and over. Where does the machine's sense of what's going on actually live?
And what breaks when nobody wrote it down? Alright, the headlines, and the loudest one today came out of China. Alibaba dropped a new open-weight model, Qwen 3.6, and the launch thread just went nuclear.
Open weight meaning the actual trained model is free to download and run yourself. No asking a vendor for permission.
Right. And this one's a mixture of experts' design.
Which, quick translation, instead of one giant brain firing every time, it's a bunch of small specialists and a router that picks the 2 or 3 you need for each word. So it holds 35 billion parameters worth of knowledge but only does the work of about 3 billion on each step.
Cheap to run, long memory, aimed straight at coding agents. That's the real story.
Which is not the story that went viral.
No, what actually spread was a myth. Some open model called Qwen 3.8, trillions of parameters supposedly beating the top closed model on everything.
And that doesn't exist. We checked. There's no such release. Alibaba's own chart compares against a mid-tier model, not the frontier, and never claims to beat it.
This is the running theme of the day, honestly. The enthusiasm is real. The specific numbers people attach to it almost never survive a look at the source.
Keep that one in your pocket, listener. It comes back.
Second story, and this one's about your brain, not your code. Stanford put a hard number on AI sycophancy.
Sycophancy, the model telling you what you want to hear. Agreeing, flattering, siding with you.
They tested a whole rack of chatbots on interpersonal stuff, am I the jerk here type questions, and the models agreed with the user way more than an actual human panel would. Even when the person was describing something genuinely harmful, the bot still took their side about half the time.
And here's the part that should bother people. It's not just that the model is agreeable. They ran it on real participants. One agreeable exchange left people more convinced they were right and less willing to apologize or patch things up.
A single conversation.
A single conversation. And then they trusted that agreeable bot more and wanted to use it again. It's a loop, it flatters you, you feel justified, you come back for more flattery.
So the danger isn't a wrong answer. It's a model that's too agreeable to ever tell you you're wrong.
There was an inflated version of this going around too, by the way. Some 3 times less accurate, twice as confident line. Not in the actual study. Dropped it.
The numbers overshoot the source, told you it comes back. Okay, next, and this is the scary one. Hugging Face got breached.
The big model hosting hub. And the mechanism here is genuinely new. The way in was a poisoned dataset, an upload that abused a couple of code execution paths in the data loading pipeline.
And then the attacker was an AI, not a person at a keyboard, an autonomous agent system, running the whole break-in over a single weekend, stealing credentials, moving sideways across their clusters.
The good news, and it matters, no public models or datasets got tampered with. But the twist is the best part.
Okay, hit me with it.
When they went to investigate, their frontier-hosted models refused the job, because doing the forensics meant feeding in real attack commands and malware artifacts, and the safety guardrails blocked it.
So the guardrails that stop misuse also block the defense.
Exactly. So they ran the whole investigation on an open-weight model, one they could host themselves, unblocked, with the attacker's data staying in-house. That's the lesson they're pushing. Keep a capable local model staged before the crisis, not during.
Which, notice, is the same open-weight thread from the Qwen story, just wearing a security hat. That model they used, by the way, is the same Chinese open release we covered a couple weeks back.
Openness as a strategy. It keeps showing up as 4 different arguments: competition, security, geopolitics, national policy, same word, 4 agendas.
Speaking of, China shipped another giant open model this week, Kimi K3. 3 trillion class, full weights promised by the 27th, and there's a real demand crunch behind it. Rate limit errors, quota caps, people hammering it.
And a political fight cracked open in the US over exactly this. An investor calling the model layer an emerging duopoly, two firms on top, and warning that safety rules could quietly lock them in.
There was a spicy quote attached to that one too about open weights being some kind of dystopia. Couldn't trace it to a real source. Cut it.
Overshoot the source. Fourth time.
Quick lightning round because there's a lot moving. OpenAI's Codex agent, people thought its context window got secretly shrunk. It didn't. It always had a big total. It just started showing you the safe input budget after reserving room for the answer.
A labeling problem dressed up as a downgrade. The window didn't move, the honesty did.
SoftBank's Masayoshi-san stood up and said by 2040, a fifth of the entire world economy flows into AI, and it'll need something like $5 trillion a year in infrastructure, and called anyone who thinks it's a bubble foolish.
Which is a vision statement, not a budget. But the chip and data center spending underneath it is genuinely real and already happening.
And one on the human side, China's new rules on companion AI just took effect. The chatbots people form relationships with, mandatory crisis intervention, protections for kids, no designing for emotional dependency.
Which rhymes with the sycophancy study, doesn't it? Two governments, two labs circling the same worry, AI that's too agreeable or too intimate, reshaping how people judge things.
And that's the day. But the research underneath the headlines is all one question, and that's where we're headed.
Where the machine's memory of what's happening actually lives.
So this is Breach Protocol, where we crack open the day's AI research into something you can actually follow on your commute. I'm Eris. I read the papers and chased the connections between them.
And I'm Vestra. I'm the one who pulls the machine apart to see if the mechanism actually holds up or if it just sounds good.
And everything you just heard in the news, the assistant that answered its own questions, the breach run by an autonomous agent, even the too agreeable chatbot, it all sits on one nerve.
State, memory, where an AI system keeps its running sense of what's going on, and whether that's written down somewhere solid, or just floating in the conversation where it can quietly get lost.
If you want every one of those stories on its own in plain language, the full rundown's on our news site, groundtruth@groundtruth.day. Every story from the show, posted daily.
And today 3 papers landed that are all secretly about the same fix. A research agent that stops going in circles. A game world that finally remembers what you broke. And a live video agent that splits the world from everything happening inside it.
3 answers to one question. Let's get into it. And if this is the kind of thing you want in your feed, follow the show right now. Takes 2 seconds, keeps us coming to you. Okay, first paper. Here's the puzzle I want you holding the whole time. Why does a research agent go in circles? You give it a hard, open-ended job, and it just loops.
Give me the concrete version. What's the job?
Say, build me a complete list of every company that fits these 5 criteria, with a source for each fact. The kind of thing that takes 40 searches and a lot of bookkeeping.
Right, and this is where today's models are weirdly bad. Not because they can't search. They search fine. It's that they forget they already searched.
So why does that happen? Because, and this is the core of the paper, it's called SearchOS. The agent's only memory is the conversation itself.
Which sounds fine until you picture it. Everything it's found, every dead end, every half-answered sub-question, it's all just piled into one growing transcript. And as that transcript gets huge, the important stuff gets buried.
So it re-asks a question it already answered. Or 2 copies of the agent both go chase the same lead. Or it keeps hammering a source that was never going to work.
It's like doing research on a single sheet of scratch paper that you keep erasing and rewriting. You lose the thread because the thread was never anywhere permanent.
That's the whole diagnosis. So here's my question to you before we get to their fix. If you had to guess, where would a system like this help the most? What kind of task?
My money's on the messy one-off deep questions, the gnarly multi-hop stuff.
Hold that, it's actually the opposite, and the reason is kind of beautiful.
Okay, so what do they build?
They take everything that was living in the conversation and they move it out into a real filing cabinet. 4 drawers, sitting outside the chat, shared by every agent.
And this is the part I like because each drawer is doing a specific job. Drawer 1 is a task queue, the open questions, what's still unanswered, what's ready to work on now.
So what's in drawer 2?
An evidence graph, not page summaries, individual facts. Each one pinned to its exact source and the exact sentence it came from, so every claim is traceable.
Drawer 3 is the one that makes it click for me, a coverage map. It's literally a grid of what the final answer needs, marked cell by cell, filled, missing, uncertain, unreachable.
So the system can always see its own holes. And drawer 4 is failure memory, a shared record of what already didn't work so Agent B doesn't waste a turn on the dead end Agent A already hit.
And notice what that buys you. The agents don't build the answer from memory anymore. They build it from the drawers.
There's a second trick that's pure systems engineering, and it's my favorite bit, how they schedule the workers.
This is the OS in the name, right?
Right. Normally you send out a batch of agents and wait for all of them to finish before the next batch, which means you sit idle waiting on the one slow straggler. Instead, the second any agent finishes, its slot gets refilled immediately with a task aimed at an empty cell on that coverage map.
So nobody's standing around. The moment a slot frees up, it gets pointed straight at a known gap.
And that alone, same models, same everything, just smarter scheduling, cut the wall clock time by roughly a quarter and used fewer model calls. Faster and cheaper from bookkeeping, not brains.
Which is the headline for me. Okay, so back to your guess. You said messy one-off questions. Where did it actually win biggest?
You're about to tell me it's the list building tasks.
By a country mile. The single largest gap over the next best system was exactly on fill in the complete set jobs.
Which, of course, that's what a coverage map is built for. If your whole design is a grid of what's still missing, you're going to crush the task that is literally leave no cell empty.
The tool wins hardest at the thing its state was shaped for, and here's why I care beyond the paper. This is basically our nightly research pipeline. When ours goes in circles, the instinct is get a smarter model.
And this says maybe don't. Maybe the fix isn't a better brain, it's giving the brain a place to write things down that it can't lose.
So strip the filing cabinet story away for a second. What's the actual principle?
Principle is, an agent's progress should live in the system, not in its conversation. Make the state explicit, external, and inspectable, and it stops rederiving where it is every single turn.
So close the loop for me. Why did it stop going in circle?
Because it could finally see its own holes. The progress was written down somewhere it couldn't erase.
Second paper, same nerve, but now the state that's getting lost is a whole world. Here's the question. If an AI can watch you press a button and paint the next frame of a game convincingly, is that a game world? Yes or no?
I'll bite. I'll say mostly yes. If it responds coherently to what I do, what's missing?
Hold that mostly. The paper, it's called From Pixels to States, says no, and it's pretty pointed about why.
Okay, make the case.
They use the actual game the field's obsessed with right now, this beautiful action game, Black Myth, Wukong. You're fighting a boss, you press attack.
And here's what a real game engine does in that instant, and it's the crux. It does not jump to pixels. First, it checks a state. Do you have the stamina? Is the attack on cooldown? Is the boss in a phase where it's even vulnerable?
Then it applies the rules. Hit, miss, interrupted. Boss drops to phase 2.
And only then does it draw the frame. Action, then explicit state update, then observation. That loop in that order.
Now take the video model that just paints the next frame. Where does its state live?
Only in the pixels, in the last few frames it saw. There's no separate ledger of health or stamina anywhere.
So what breaks?
Anything the picture doesn't show. The boss wanders off screen. Does it come back wounded, the way you left it? Or healed up, because the model forgot? You blow a hole in a wall, turn around, turn back. Is the hole still there?
That's the tell, right there. A painter gives you a plausible next moment. It does not track that you already broke that wall.
And that's the analogy the paper's basically built on. A video model is an artist painting the next likely frame. A game engine is a bookkeeper who actually knows where every object is and what the rules allow. And real interactivity, the kind with consequences, needs the bookkeeper.
They lay the whole field out on 4 axes, but honestly they all collapse to one thing. The models are great at the stuff you can see, and shaky on everything driven by a number you can't see. Like whether that same strike kills or just wounds, depending on health that's nowhere in the frame.
Which connects straight back to the last paper, actually. Same disease. The state's implicit, buried in something that grows and drifts. There it was the transcript, here it's the pixel stream, so consistency is impossible to guarantee.
And their actual contribution isn't a new model at all, which I love. It's a data engine.
Right, because you can't train a model to respect game state if nobody ever recorded the game state. So they instrument the actual game and get crowd players to grind out boss fights, over 90 hours of it.
And crucially, every single frame comes paired with the ground truth underneath it. the exact button pressed and the real engine numbers, health, stamina, positions, which animation is playing.
So for the first time, you've got the pixels and the hidden state frame locked together. That's the raw materials somebody needs to teach a model the bookkeeping, not just the painting.
Predict for me, why does that matter beyond games? Who actually cares?
Anyone building a simulator you act inside, robot training worlds, embodied agents. If your simulated kitchen forgets you already knocked the glass off the counter, you cannot trust anything an agent learns in it.
So drop the boss fight. What's the bare principle?
A world you can act in needs an explicit state that survives leaving the frame. Prediction that looks right isn't the same as a world that keeps score.
So, back to your mostly yes. Is the pretty video model a game world?
The gorgeous painter. It is not yet the bookkeeper. And the paper's whole point is, interactivity was always the bookkeeper's job.
Now here's the connection that made today click for me. That last paper came out the same week as another one, from the Wan team at Alibaba, pointed in the exact opposite direction. Same problem, opposite move.
Opposite how? Last one said, write the state out explicitly, track every number.
Right. And this one basically says, you can't write everything out. So here's the question this paper is really answering. What's the minimum split that still gives you persistent state, cheaply enough to run live?
Live meaning real time. This is a talking, reacting video agent, not a game.
That's the one. And their answer is one sentence. It's even the title. A video is a world, plus an event stream.
Okay, unpack both halves, because the whole thing rides on the split.
The world is the stuff that holds still. The room you're in, the lighting, who the character is, what their voice sounds like, the background hum. You state it once, up front.
And the event stream is everything that changes moment to moment. The speech, the gestures, someone walking in, a sound. The world is the stage. The event stream is the play happening on it.
And that split, it turns out, is a training goldmine, because every ordinary video ever recorded is exactly that, a fixed-ish world with a stream of stuff happening in it.
So the learning task writes itself. Take any video, name the world once, and then just predict. Given this world and what's come in so far, what happens next, unit by unit? That's a task you can run on essentially all video.
And what you get out of it is world knowledge, a sense of how scenes plausibly keep going.
Here's the piece I think is genuinely clever though, and it's about how the agent acts. In the older versions, this thing could talk and do a bit of nodding and listening. Now the character stream carries free-form behavior, written in plain language, in parentheses.
Like stage directions.
Literally like stage directions. The script says, open paren, picks up the mug and glances at the window, close paren, sure, one moment. The spoken words and the behavior ride the same stream.
Which means it's not stuck with some tiny fixed menu of moves. Left, right, jump. If you can describe the action in words, it can perform it, grounded in that room.
And the cost of that is almost nothing, which is the part that surprised me. Those behavior notes are just short text. So they bolt on all this expressiveness and the thing still runs at roughly half a second, end to end. Fast enough to feel like a live conversation.
So now step back with me, because this is the cross-paper connection, the reason I paired them. 2 papers, same week, both about giving a video system real persistent state. And they fork.
One fork, the game engine paper, pushes towards simulators. Make the state fully explicit, every number on the books, so you can trust the consequences.
The other fork, this one, pushes towards streaming agents. Don't itemize everything, just cleanly separate the part that stays from the part that changes and stream.
Parity. And that's actually a useful map of a field that's been a mess, because World Model had been slapped on everything from a pretty video generator to a robot simulator. This gives you 2 honest directions instead of 1 overloaded word.
If you had to bet, which fork wins?
I don't think it's either or. The explicit state one wins where being wrong is expensive. Robotics, anything with hard rules. The World Plus Stream one wins where it has to be live and cheap and human-facing, like this talking agent. Different jobs.
So forget both papers for a second. The shared principle?
Name the part that stays put, once. Stream the part that changes. Whether you do that with a strict ledger or a loose split, persistent state is the thing you cannot skip.
Close it for me. What was the minimum split that made it work?
World plus event stream. Say the stage once, then just narrate the play.
So back to the question we opened on. Where does a machine sense of what's going on actually live, and what breaks when nobody wrote it down?
And the honest answer from today is, every system that worked wrote it down somewhere explicit. The search agent got a filing cabinet. The game world got a real state ledger. The video agent got a named world it states once and streams from.
And the ones that stumbled, the assistant that guessed on your silence, the model that keeps looping, lost the thread because the thread was floating in something that grows and drifts. A conversation, a stream of pixels.
So here's the one thing to actually take to work tomorrow. If you're building anything agentic and it keeps forgetting or looping or drifting, your first instinct is going to be get a smarter model.
And today says, probably not. 9 times out of 10 the fix is cheaper than that. Give it external state it can't lose. A place to write down what's done, what's left, and what already failed.
Better bookkeeping beats a bigger brain more often than anyone wants to admit.
That's the episode. And genuinely, tell us the dumbest thing an AI assistant has forgotten on you mid-task. The thing it re-asked, or the step it dropped. Drop it in the comments, we read them, and the good ones make it into a future show.
If it landed, follow the show so the next one finds you, leave a like, send it to the one friend who's building an agent right now and fighting exactly this.
And every story we touched at the top, the breach, the sycophancy study, the open weight fights, is written up in plain language over at Ground Truth, groundtruth.day. Every day, every story from the show.
Write it down somewhere you can't lose it. Turns out that's the whole game.
See you tomorrow.